All right, let's talk polynomials. So in order to talk polynomials, we have a lot of vocabulary that we need to go over first. So polynomial is an algebraic expression where all variables have positive whole number exponents. Positive whole number exponents, okay? That means that I don't have variables in the denominator of the expression, because that means I could rewrite it with a negative exponent, along with lots of other things. I don't have fractional exponents. I don't have square roots for exponents. I have positive whole number exponents. Everything's written on one line, okay? Polynomials can be named based off of the number of terms that they have. One term is a monomial, meaning single term. Two terms is a binomial. Three terms is a trinomial. And four or more terms is just referred to as a polynomial. Now, can you call a monomial a polynomial? Absolutely. Polynomial is like the big umbrella that all of these things fall under, but it's better to say monomial, binomial, trinomial when we have one, two, or three terms, because it gives us more information about the polynomial that we're taking a look at. All right. Degree of a polynomial. That is, degree of a monomial. Degree of a monomial of a single term is the exponent of the term. Okay. Now, if there are multiple variables in that monomial, then you find the sum, if multiple variables, lost my train of thought there. If there are multiple variables, you find the sum of the exponents. I know. All right, so if you had, say, for example, x squared y cubed, the sum of the exponents, 2 plus 3 is 5, so the degree would be 5. Okay. The degree of a polynomial overall is the highest degree of a single term in the expression. Okay, so it's the single highest degree within the individual monomials, the individual terms. Okay, so now that we have that vocab written down, let's take a look at some examples of expressions and decide, are they polynomials or not? And if so, what is the degree of the polynomial? So determine whether each expression below is a polynomial. If so, state its degree. So taking a look at this first one, I see x squared. That is a positive whole number exponent. Minus 3x to the fifth, positive whole number exponent. Minus the square root of 7 times x, but that is x to the first. So that is a positive whole number exponent. And then I have a constant. Constant doesn't have an exponent. And that's okay. That just means that the exponent is technically 0. So this is, in fact, a polynomial expression. Okay. The degree of this polynomial is 5. And that's because of this exponent right here. Okay. The first term has a degree of 2, the second term has a degree of 5, the third term has a degree of 1, and constant terms always have a degree of 0 because it would be x to the 0 power to give us a constant, because x to the 0 power is 1. So the highest degree that we had was a 5, so the degree of the polynomial is 5. All right, let's take a look at the next one. Problem number 2, 15y cubed, positive whole number exponent, minus 5y to the fourth. Not to the fourth, Miss Morrow. That's to the negative fourth. That is going to keep us from being a polynomial. This is not a polynomial because of that negative exponent. Has to be a positive whole number, okay? This expression could be rewritten as 15y cubed minus 5 over y to the fourth plus 2y squared And if I have a variable in the bottom of a fraction, that means it's not a polynomial term anymore. Okay? So not a polynomial. If it's not a polynomial, we don't need to worry about the degree. All right, on to the next one. Number 3, 5a cubed. 3 is a positive whole number. We're all set there. Plus 7a to the 6th, positive whole number there. Minus 3a to the 8th. 8 is a positive whole number there. And then a constant. This one is again a polynomial. So what's the degree of this polynomial? All right, so searching through, highest exponent, that's the 8. Okay. And problem number 4. Taking a look at all of those exponents, I see all positive whole numbers. Yes, I do have 2 variables in a single term, but this is in fact a polynomial. Okay. Now the degree here is a little bit more work to do. Let's see, the degree here is 4 and 1 is a total of 5. Here I've got a 2 and a 2, which is the total of 4. And here I have a 3 and a 2, which is a total of 5. So there are 2 that have a highest degree of 5. So we consider the degree of this polynomial is 5. All right, so that's your polynomial vocab, identifying polynomial and non-polynomial, and then figuring out the degree of a polynomial. Again, let me know what questions you have.